Okay, so we are ready for the last presentation of the day, using Python to generate automated QC reports against Petrel by Neal Coles. Neal Coles is a senior software developer and product owner. He is the architect behind our very popular Blueback Investigator product for Petrel, and he is involved in almost all of our Cegal geoscience software portfolio. He's been involved in software development for 25 years, and he's been with Cegal for, as far as I remember, 10, 11 years or so. And by that, I will be handing over the presentation to Neal. So here we go.
Thanks, Rennie. Just let me share my screen, and then hopefully we'll be good. That one. Can everybody hear me okay?
We hear you good, but we're not seeing the presentation. Yeah, there we go. All right, thank you.
Right. Okay, perfect. Okay, yep. Let me just, Okay, thanks for that introduction, Rennie. Yes, I have been with Cegal for 10 years. It was my 10th anniversary last week since joining Cegal. So, welcome to using Python to generate automated QC reports from Petrel. Thank you for staying on to listen to me. I suppose it's not late for you guys, actually. It's getting on for me. Okay, so over the last few years, I've attended numerous Python presentations, either internally within Cegal or externally, a bit like this workshop. And I've noticed that it's very common to see plots and QC plots in particular within people's Python notebooks. But often these plots are made using packages like matplotlib or plotly or seaborn. There's lots of different packages you can use in the Python environment. And these packages are very easy to use, and you can display simple plots very, very quickly. But what I noticed as the lead architect for and product owner for Blueback Investigator was that the more you try and customize these plots to ensure that they're consistent and that they're showing the same data, the more difficult it gets in the Python environment. So much so that sometimes you see plots with different colors or shapes or data ranges that are actually supposed to be showing the same sort of thing, but it's not always easy. It's not always obvious that these points are sands and shales or any other sort of discriminant type in one plot compared to a notebook in another plot. This can be particularly frustrating if you're looking at presentations from different companies, but even more so when different teams seem to plot the same data in different ways. And it can make comparison of these plots very difficult. So we wanted to try and ensure that you could have a bit more control over the plots that you were making in your Python, and that you could do it simply. It is possible to make plotly plots more complicated and to provide the sort of plots that you're used to seeing as a geoscientist, but that involves you writing more and more Python code. And once you've got that Python code, you're going to have to, develop it. You're going to have to test it. Potentially, you're going to have to make that Python code, and you're going to have to share it with colleagues or across your whole company. Then you've got to maintain it if other people are using it. Perhaps people are making changes to it. How do you ensure that it's consistent if you've got multiple Python users all trying to make plots across your company? It's also easy to make a scatter plot or a histogram, but if you want to start showing, a net porosity for a zone as a map, or an intersection through a 3D model, and comparing that to a well section data, then that's a bit more complicated, and it's a bit more geospecific than what most of the Python libraries that you've got at the moment can do. So the spatial data, enriches the plots. It gives additional meaning that's important to the geoscientist. You're not just looking at the values of the samples. You want to know where they are. What zones are they in? Where are they spatially in relation to the well and things like that? So you want that extra information to enrich the data experience as a geoscientist. Okay. So having sort of viewed this challenge and this problem, we decided that we would try and come up with a way to make plots have a consistent look and feel across any of the notebooks that you make within your company, no matter where the data came from, so that you can actually try and have a communication, have a discussion about these plots in a sensible way. Okay, so we also realised that we have a product called Blueback Investigator, as Rennie said. Hopefully, most of you know what it is, but some of you may not have heard of it, so I'll give a quick overview of it here. But this forms a good grounding for us to build the sorts of plots that we think that you want to make as a geoscientist in your Python notebooks. Okay. Blueback Investigator is a plugin for Petrel, and it's designed to do cross-domain data analysis. And there's lots of different visualization options that it provides you within Petrel, and you can see some examples on the slide here. But importantly, to view data in Blueback Investigator, you have to make an investigation object. And this investigation object allows you to relate the different data samples from the different domains and all the relevant spatial information, MD, values, TVD, two-way time, for each of the different data sets that you're interested in a consistent way. Now, it does that using Petrel templates, and it uses the templates to connect the properties across the different domains. So it enforces you to make sure that you've selected a porosity well log and a porosity model property and a porosity point set attribute. And it ensures that the units are consistent, that the type of the measurement is consistent. It handles sampling issues, and it ensures that all the data is spatially located as well. Okay, and effectively what we're doing by creating this investigation object is we're cleaning the data. We're ensuring that we're starting with a nice, clean data set that we can then continue in the Python environment to use. Okay, so that's your data in Petrel. Last year, we introduced InvestigatorPI, and InvestigatorPI was targeted at data scientists or at geoscientists who want to start using Python, and it was designed to allow them to access these investigations from within a Python environment. Okay, which means that you've already handled all the data cleanup. You're not now, a lot of Jupyter notebooks that you see these days start with a LAS file or a SegY or a CSV or something like that. But you need to know where your data comes from, and you need to ensure that your data is clean. So by starting from the investigation object that you've already made in Petrel, we've already done a lot of that cleanup, and we've ensured all that consistency. Okay. And InvestigatorPI allows you to take the data from an investigation and to use scikit-learn and some of the models that Thomas just showed you to create regressions and classifications. And you could then take these trained models back to Petrel to run them on other data sets within the Petrel environment as a geoscientist. Okay. So what we've now done is we've produced an extension to InvestigatorPI, which is currently called InvestigatorPI Reporting. The name may change. What it allows you to do is it supports all of the plots that are currently available in Blueback Investigator for Petrel, and some additional plots that I'll show you soon. And it allows you to get access to all of those and render all of them within your Python notebook, right? We aim to have a simple Python API. It should be concise. It shouldn't be intimidating for a geoscientist to use. Okay, you shouldn't have to understand a huge amount of Python to do it. The aim is that basically any plot that you can make in Petrel, you can now make in your Python notebook with a few lines of code. And it is a few lines of code. I'll show you some snippets in the demo. Okay. Importantly, all of the rendering of all of the images that you're going to see all happens in Petrel. So we're not transferring any of the data out of Petrel across to Python to generate these images and these plots for reporting. We're actually generating the same image that you would see if you were to look at the data in Petrel, and we're just passing that image back across to the notebook for rendering. Okay, this has some advantages. We're not having to pass millions and millions of model data points across to Python. You know, the data is already in Petrel. We know where it is. You know, it's under data management policies. We just access it. Okay, you can get the data from Petrel into Python as a data frame, for example, if you want to. That's what InvestigatorPI was originally designed to do. But this extension is just about, at the moment, about getting the data for the report. So it's about making the plots and rendering them in the notebook. Okay, we're currently targeting a Model QC workflow, and that's what I'm going to show you now. But this is a generic solution. You know, anything that you can load into Blueback Investigator, you can plot in your notebook effectively. Okay, so it doesn't have to be well logs and models. It could be point sets, or it could be surfaces, or it could be seismic. Okay, or it could be simulation results. Okay, so yeah, so this is a Model QC workflow. So basically what we're going to see, if I just go to Petrel now, can we see Petrel? Yep. So this is the Groningen field that was open sourced. The data for it was open sourced about a year ago, I think. And we've got the little red box represents the area of the model that we're actually going to use for the reporting, but we could use the whole model. I've shrunk it down for basically for the speed of the demo, to be honest. And in this, we've got about 20 or so wells. We've got a number of different model properties, and we're going to do some simple QC and look at some plots that we could make. Okay. So there's Petrel running. I've also got a Jupyter notebook running. Okay. Here's my Jupyter notebook. And using Cegal Hub, which Sebastian talked about earlier, I have connected my Jupyter notebook to my running Petrel. I've attached to my investigation, and I am now ready to make a plot in my notebook. So the first thing I'm going to do is I'm going to just say to InvestigatorPI that I want to make a cross plot from my investigation, and I'm just going to call it a simple plot, and I'm just going to plot it. Okay, so without doing anything, 2 lines of Python code, I have taken my investigation, I have made a simple scatter plot of the first 2 dimensions from my investigation. Fantastic. Well, that was quite easy. That's good. But the whole point of this is that you could generate reports from it. So I want to tidy this plot up a bit. It's not very pretty. You know, these names, they're a bit long, and they probably shouldn't say Cegal base. That's, you know, maybe we should tidy it up a bit. So I can now use InvestigatorPI to start manipulating the investigation that I'm currently using. So I'm going to clean up some of the names. I'm going to set the precision that I want some of the information displayed to in decimal places or significant figures. I'm going to set some ranges that I want to use. Okay. And I'm going to rename my fasces property because I know that it's got a really bad name. So let's see what I've got now. So I've already tidied it up a bit. I've got some better names, right? Okay, good. I've got the units on are a bit nicer. You know, I can change the units if I want. I'm going to create some useful variables now just to make it a bit more readable later on so that I know what I'm referring to. And importantly, this investigation has all the spatial information available to it as well. So I want to do model QC, and an important part of that model QC is going to be looking at how the well logs, the raw well logs, relate to the upscaled cells, and then how the upscaled cells relate to the model. Well, I've actually not loaded the upscaled data into my investigation. I only loaded the full grid and the well logs. So I'm going to calculate, first of all, the borehole intersections with my grid. And if I do that now, I'm just going to set them to be some different shapes, and let's just see what I've got. So I've now got a simple plot where I've got my my model in blue, my wells in red, and then my upscaled cells are now these sort of dark blue triangles. Okay, let's start doing some more interesting plots then, shall we? So let's start with some histograms. So everything in InvestigatorPI reporting is based off what we call a view. So the first thing you have to do is you have to, in the first line here, is we make a view by saying, I want a new histogram view based on this investigation, okay? And then you can manipulate the view with lots of very simple calls. So I can control what data sets I want to see, what discrete properties I want to look at, what count axis I want. Do I want to apply weighting to my values? Do I want to show the legend? That sort of thing, okay? So I've defined a sort of base view, my default view as I'm calling it here. And the first thing I'm going to do is I'm going to make a weighted histogram split by fascies, showing me my wells versus my upscaled cells versus my model, okay, for my porosity information. So there is a histogram split by my different fascies, showing my porosity data, where each of the different coloured bars represents my original well log data, my upscaled cells, or my full model grid. Okay, and I can make exactly that same plot in Petrel using Blueback Investigator. Okay, but I can do some other things now as well. I can make a box plot by zone of all my properties. And it seems to run a bit slower when you run it under WebEx. There we go. So here we go, we have a box plot of each zone. So the background of the plot is coloured by the zone colour. And on top of each zone, you can see the box plot for my 3 continuous properties that I've got. Okay, that's quite nice. I might use that in a report. That looks quite useful. I might also want to look at the proportion of fascies per zone. So let's have a look at that. And again, you can see that once I've set up my default view, I only have to write a couple of very simple lines to describe how I want the plot to appear in the notebook. Okay. And I can control the size of it, the width and the height and things, or I can just leave it as default. Okay, so there's a proportional histogram by zone. Okay, that's good. So as well as doing histograms, I can also do scatter plots or cross plots, as they're often called. So there's a cross plot of pore perm coloured by water saturation, split by fascies. Or I could create 2 plots this time. So I'm going to create 2 plots side by side because that's a bit busy. I can't really tell what's going on there with my wells and my upscaled and my grid all in the same plot. So I'm going to split them up. So I've got wells versus upscaled on the left, and I've got upscaled versus grid on the right. Okay, yeah, again, these are all useful plots. I think I could put these in some reports quite easily. Or I could make some matrix plots. So again, to make a matrix plot, I just create a matrix view, and I can set what I want to show and how I want that view to appear, and it simply appears. Okay, now that's far too busy. I can't really tell what that's trying to show me. So rather than showing me all the properties this time, I'm just going to plot the means for each zone, I think. Well, that's maybe a bit more interesting. Certainly got a lot less data on it. I can see a bit clearer what's happening with the mean for each of the properties in each of the zones and how they relate. Okay, so all of the plots that we've seen are all plots that we could make in Blueback Investigator in the current release version. But we also now have access to log tracks. So now I'm going to take that investigation data, but I'm going to draw it as you would see in a well section window or a log view. So exactly the same information on exactly the same investigation, and I can see my my wiggles now for 2 wells, and my zones and my fascies. Okay, and I could do the same again, but this time I want it grouped by property. So I've got my 2 SWs and then my 2 poros, my 2 perms next to each other. Okay, and I could do exactly the same, but this time rather than just looking at the raw well log data, I'm going to look at what the upscaled cells are along that borehole trajectory as well. So you see on the left the original raw well log, and on the right is the upscaled cells for that well trajectory. So okay, that's quite good. That could be quite useful in our report. The other thing that we can now do in the new version is we can create intersections. So very simply, I'm just going to create a north-south intersection through my model. So that's the model cells projected onto or intersected by this north-south line, coloured by porosity. And importantly here, the colour that I'm using in this intersection, you know, the colour of these cells here, the colour, the porosity values represented by these colours, is exactly the same as the porosity values by these colours in this well log section, and is exactly the same as the porosity values in the cross plots or the histograms if you colour by the same property. So it's consistent across all the different plot types. We know that we're going to see, you know, the same green for porosity across all the different plots represents the same porosity value. Okay, and that's actually quite tricky to do on a lot of these other plotting packages. Okay, and I could do an east-west intersection. Again, in the same way, but this time, rather than just a single property, I've actually asked it to make me multiple properties here by just passing in an array of the properties I want. And it's going to make me a multi-plot, hopefully. There we go. So again, that's the same east-west intersection now plotted for water saturation, porosity, permeability, and facies. And I can start to make maps as well. So here's a simple porosity map at a selected number of Zs. So basically, I've used a little loop in Python to loop over the depth range of my model and create me an intersection every 50 meters, and then plot that. So I can see it Z 2750, 2800, etc., down through the model. And I can do that for any of the properties that I've got. Or rather than looking at a Z, a fixed Z value, I could look at it for a K layer. So here's the same sort of thing, but this time I'm looking at K25, K50, K75, and I've displayed the boreholes over the top so you can see where they are. Okay. Finally, we can start to ask for things like thickness maps and net porosity maps for these zones, because all that information is in the investigation. Blueback Investigator and InvestigatorPI knows how to collapse that information together and to produce a thickness map for a zone. So here we see thickness maps for the first 3 zones. Okay, and I can do the same for net porosity and lots of other properties. Okay. So what I was trying to prove here is that, you know, by writing a very few lines of Python, I can start to make the plots that a geoscientist are expecting to see, but within a Jupyter notebook. And I can make it very simply. And importantly, I can make it reproducible, because I can take those little fragments and I can build a template report from them. And then I can use a technology called Papermill to generate me a report. So what I did was I have made this report template. Lost my mouse. There it is. And in this report template, you know, and we can provide examples of how to do this, you can see very similar little snippets of code defining the plots that I want to make and how I want them to be displayed. Okay. And then I have some loops. So I'm going to loop over all of the wells in my investigation, and I'm going to produce a section of a report. So I'm going to show you that report now. Okay. So here it is. So basically, I looked over every well in my investigation, and I made a consistent set of plots showing the raw well log data versus the upscaled cells for that well. And I also started with a little map to show me where that well is within my area of interest, my model. And you can see these are the same plots that we showed before, but I generated that for every well in my project. and I just wrote them all out to a PDF file. Okay, and then I thought, well, I've done all the wells now. What might be interesting would be to then look at the model data. So if I go down to about halfway, there we go. So then I thought, well, what I'm going to do is I'm going to look at the upscaled properties versus the model properties for each zone. And I'm going to do it zone by zone this time rather than well by well. So again, I made a set of box plots and just a matrix plot. And I repeated that for every zone in my model. And then I thought I'd just make a little summary. So I made a whole load of north-south intersections automatically for each of the properties. And I made a whole load of east-west intersections as well, I think. Yep. And then finally, for each zone, I made a collection of maps. I made a depth map, an isocore map, thickness map, a mean map, and a fascies, most common fascies map. So, and I repeated that for every zone in my model again. Now, if I was to try and make all these different plots in Petrel one by one for a presentation or for a report, it's going to take me quite a while. But with this notebook, I generated this report in about 10 minutes. And if somebody goes and changes it and makes a change to the model, or we get new data, I can generate exactly the same report again on the new data in about 10 minutes. So I think that is a big game changer because it lets you as a geoscientist to stop worrying about making your plots and making your reports and generating all these images and putting them in PowerPoints. Hopefully, you can start to use technology like InvestigatorPI Reporting to make these reports and these plots, and you can get back to doing the proper geoscience work that you're actually interested in. Okay. I can also take my report that I've run against this model, and with a few changes, I could run it against a completely different model and a completely different set of wells in another project. You know, and one of the things we're looking at is whether we could take these templates and we could, for example, run them overnight on a set of Petrel models that we can find using Cegal Hub. So using Cegal Hub, we could find a Petrel project, we could open it, we could find the model, we could find the well logs, we could make an investigation, and we could dump out a report. And then we could close it all down and move on to the next Petrel project. Okay. Importantly, though, once again, I want to reiterate that these plots are all consistent across all the different types of plot. So you know what you're looking at. And you can ensure that across multiple reports from different projects as well if you want. Okay. So that was the demo. Yeah, so I've just shown you an example report where I used the InvestigatorPI functionality and then the extensions in InvestigatorPI Reporting to generate hundreds of consistent plots in a matter of minutes. And it is. Okay. So what are our plans for the future for this? Well, you've just seen it running inside Petrel. But once we loaded the data into the investigation object from Petrel, we didn't actually use Petrel for anything after that. So we have ideas to make it run totally standalone from Petrel. And I can do that at the moment using the InvPy file that is used by InvestigatorPI. So I could run this in a standalone application. I could import my InvPy file and I could generate all these reports with all these plots without having Petrel running. Okay. We would like to integrate this with Python Tool Pro. I mean, that's the obvious one, I think. You saw in Sebastian's presentation that he made multiple plots. He made some log tracks, and it would be nice if they were all consistent and they had the same look and feel that you as a geoscientist were used to. Okay. We also think we can make it work on any data source, so it doesn't actually have to come from Petrel. So we have a prototype where we can take a standard pandas data frame and plot it using this technology, standalone without Petrel. Now, we need to solve the problem of how we get all the spatial information into that data frame if you want to start doing intersections and map aggregations and things. But you know, we could investigate that further. All the plots that we've shown in the notebook are currently static. They're just bitmaps that are being displayed in the notebook. which is really useful because it means that you can take the notebook and you can send it to a friend or a colleague, and they can open it and they can see the same plots. They don't need to connect to Petrel once they have a saved notebook. Okay, you only need to connect to Petrel or to InvestigatorPI to regenerate the notebook. Okay, but it would be even nice. It'd be even more exciting, I think, if the plots were interactive. So we've got another prototype in the works where, rather than it being a static image, we embed a small web page, some HTML5, and into that HTML5 we interactively render the investigation. So you wouldn't even have to write the small snippets of code at that point to set up how you want the plot to look. You could customize the plot interactively, much like you do when you're using the Blueback Investigator within Petrel, with the same sort of toolbar options and context menus. And once you're happy with the setup of the plot, you could click a button and generate the little bit of Python that you need to set your plot up that way in the future. So that helps you even learn how to code the Python. Okay. So what's the plans for release? Currently, we're hoping to release this alongside Investigator 5.4, which will be around the end of this year. We want to make the reporting as easy as we can so that you can focus on the geoscience, not on the Python and not on the PowerPoints and the images. Okay. But like all the products from Cegal, it's a client-driven project. We want feedback. Is this something you're interested in? Are we missing something that would make it so much more useful to you or your company? You know, give us some feedback. We hopefully reach out to some people soon for some beta testing if you're interested. Again, let us know. Okay, are there any questions? If not, thank you for your time.
All right, Neil, thank you so much for giving us a little glimpse of what is happening in the R&D department in the UK software development team. Let's see here. We have a question here from David Middleton. Very cool, Neil. What is required to run this on premises, and what is the overlap with Blueback Blueprint?
Okay, good question, David. So to run it on premises, it's exactly the same as for InvestigatorPI or Python Tool Pro. Basically, you just need a Python environment. You will need this new thing that we've got called Cegal Hub, which facilitates the communication between Petrel and the Python environment. But yes, you can run it all on your local desktop, or you can run it with a local Petrel and Python in the cloud, or you could run it in theory with all of it in the cloud if you wanted. So we think it's got a very flexible sort of deployment options. Yeah. What are the overlap with Blueprint? Right. So there are a lot of similarities between what I've just shown and Blueprint, but there is also some functionality in Blueprint that we can't currently support with InvestigatorPI reporting. So at the moment, there are no intentions to retire Blueprint or to replace it with this, because there's a difference in the functionality. That being said, the InvestigatorPI reporting, I think, is much more general. Blueprint is specific to a model QC workflow. We could use InvestigatorPI reporting to generate plots for any data type, any data set that we have in Petrel and Blueback Investigator. So you could imagine it using, you know, I don't know, you could run it on seismic data and you could generate plots of different seismic data. You could use it to compare different models generated by some sort of machine learning ensemble thing in your Python environment. It's far more flexible and far more generic. You know, you don't have to use models. You could just look at well logs, and you could generate a series of rock physics reports almost on your petrophysical to your rock physics, just on your well logs. So I think InvestigatorPI reporting, you could maybe think of it as the future of Blueprint at some point, but it's not there yet. Blueprint is still there, and it's still a product that is being supported and by us.